What's up? All right, so what we want to do with to get the reaction started is we got to make sure we got our 3 milliliter conical vial. Bada bing, bada boom. What we're going to do is we're going to have our reflux water jacketed reflux condenser, and we're going to have that sitting right on top of that, right? But what was the thing that we needed right here? We needed to make sure that there was something holding it together and sealing that, sealing this little joint up. And so what we're going to do is we're going to take this lid, put that on there, right? And then we also take this O-ring right here, okay? And we're going to slide that over, okay? And we want it to be pushed past that this ground glass portion right here. And so that way our lid stays without being held up by us. And so we can set that right on top of here. And then as we turn that in there gently, we tighten that up and this guy doesn't come out. It's got a nice seal there, okay? So that's basically what we want to have set up, but of course we got to get our reagents in there first. And the prep calls for 120 milligrams of para-amino-benzoic acid. So also known as 4-amino-benzoic acid. Warning, it's an irritant. Okay, so again, 120 milligrams. What I've weighed out here, because you don't want to watch that, is I've weighed out 146 milligrams. That's a little bit too much, right? I wonder if the reaction will proceed. Let's see what happens. The point of this right here is just I scooped some on there, and I happened to get around 146, which is like kind of close to the required 120 milligrams, but I don't want to spend too much time at the scale, right? So sometimes it matters to be really precise, sometimes it doesn't. I guess we'll find out if this is one of those cases where it does matter, right? So what we're going to do is we're going to pour that in here, okay? So remember, this is 146 milligrams. Oh, I'm about to drop it. Gotta focus. I can't talk at the same time right now. This wave paper is being weird. Okay. See that? It's kind of little, you can't see it. Oh, a little staticky. So again, that was 146 milligrams of the para-amino-benzoic acid, aka 4-amino-benzoic acid. And so now that we've got that in here, what we want to do is we want to add 1.2 milliliters of absolute ethanol, or 200 proof ethanol, or 100% ethanol. So 200 proof is basically, it's another way of saying it's 100% ethanol, okay? So if something were 80 proof, it would be 40%. Oh, I'm sorry. Yeah, you cut it in half. So there you go. Sorry, I was thinking and doing that at the same time. So what I've done is I've added 1,000 microliters, and now I got to go ahead and adjust my numbers so that way I can get the 200, because I want 1.2 milliliters. And so I got to change this up a little bit. I'm not going to get too crazy. Boom, boom, boom. Is that close? It's close-ish, right? So let's pop that bad boy in here. We're going to go ahead, and what I'm doing is I'm going to probably try and get it on the walls, so that way any of the material that was stuck on the walls ain't going to be stuck anymore. Okay, now, see this right here? This is a spin vane, right? The triangular stir bar. It's a magnetic bar or magnetic triangle. And we're going to place that inside of here. Okay? And what we're going to do now is go ahead and connect everything. Boom! Right? Now what we want to do is stir this until it dissolves. So that's what we want to do before we move forward. So I'll go ahead and get that started, and then I'll give you a look-see. Okay, so as you can see, that's stirring. Okay, I got the stir on like 6.5, 7, and you just want to put it to whatever will get it as a consistent stir. You also want to make sure that it's centered on that stir plate, otherwise it won't stir very well. Also, what I have going is got my water bath heating up because we will eventually start heating this reaction. We want to reflux this for about an hour, maybe 75 minutes. We'll take a look at it at that time. But so for now, all I'm going to do is have that stirring until that white solid dissolves. Okay, so we'll see you in a minute. All right, so you can see it's getting better. I turned it up to 10. I would have turned it up to 11 if I could. The one thing about that is that if you turn it too high or too low, sometimes it won't stir at all. But I kind of messed with it, and then we got it stirring at a good rate, even at that high spin rate, that high RPM. So I'm gonna leave it there, so that way we can kind of get everything dissolved, right? And so what I've also been doing is setting up my hoses for this water jacketed condenser, because we are going to be refluxing our reaction, which means heating it up and boiling the solvent, right? So we want cool water running through there, so that way we can condense those vapors and back into a liquid, so they go back down into the conical vial, so that way it doesn't dry out and the reaction can proceed. Okay, so always work while you're waiting on stuff, okay, no matter what. All right, so now what we want to do is start adding our sulfuric acid. Remember, 18 molar is concentrated sulfuric acid. That is very corrosive, super strong acid. So we're gonna be careful with this off. So what I'm doing is I'm taking this top off for now, just for now. I'm gonna gently place this down so it's safe somewhere. And I will clamp this bad boy back on here. You can see that this is not stirring anymore, right? So let me turn this stir down, because once you start getting it stirring again, it might start to jump around. It might start to get out its seat and jump around. All right. Cool, so we've got that at a controlled rate of stir. Now we're gonna add 0.100 mils of sulfuric acid, so that's 100 microliters, okay? All right, and we're gonna add this dropwise. We wanna add this dropwise. We also wanna make note of what's happening when we do it. I'm gonna lower this clamp so that way we can get it closer to the stir plate. So that way the stir is a little bit better. Looks like it's just vibrating a lot. it's not doing a good job of stirring the top portion, so I gotta fiddle with it a little bit to see if we can get that top solid material kind of mixing in before I continue to add. Okay, so bear with me. All right, so we did our best. I think I got a tiny bit of acid on the outside, so you always want to be aware of that because you don't want to touch the outside with your gloves and then have the chemicals on your gloves and then think your gloves are clean. So what I'm going to do is set this up and immediately change my gloves. First things first, I'm the realist. Put this guy on. Let me see, make sure this is stable, very secure. I'm probably gonna, let's raise this up. You can't see it anymore, but I'm gonna clamp on the water jacketed condenser, okay, and then I'm gonna put it in the heat. Alright, so what we've got is our reaction is stirring now. Okay, and we've got our stir at 9, our heat at a little over 4. And it's clearly heating. We got condensation on our water jacketed condenser, which we definitely remember how to check and make sure if our water flow is good enough or flowing at all. So first you can look for bubbles flying up. Let's do a little tap-a-roo. Nothing going on there. So what we can do is check the sink and it's flowing. So we've got the water flowing and it's doing its job, right? It's condensing the water on the outside, so it should condense the ethanol on the inside. Because remember, our ethanol is our solvent here. It's also reacting with the para-amino benzoic acid, right? Now the goal for this setup right here is to heat it up and basically reflux it for 60 to 75 minutes, okay? So what was refluxing? It's boiling, right? So if it's ethanol, what should we heat it up to? Around 85 degrees, right? And so that's why I've got this thermometer in here as well. Number's a little dark, but it's around 80. And notice that the thermometer is not touching the bottom. That's the way you should have it set up, okay? And you don't want it to be, too high. You also don't want it to be too low. I'm pretty cool with like 80. I am gonna allow it to go up, but I don't want it to go up too much higher. I also want to keep an eye out for the reflux occurring. So we want to see some vapors go up. Obviously that's hard to see, right? But the way we can tell is that they're going to be condensing on the water jacketed condenser and they'll be dripping down. So I saw a little action inside of the conical vial, so I know you can see it kind of, it could be on the outside, I guess, but what we should eventually see is liquid dropping down, okay? So we technically can't start our clock until we've got it refluxing, aka boiling, okay? All right, so we got it at 85. Still stirring well, heating okay. So one thing that happened that I want to make note of is, see all that condensation on there? It started to drip down. Sorry, it started to drip down and kind of collected right here in this area. That's not good. We're still going to move forward with the reaction. But the reason why that's not good is because water can, if it gets inside of the reaction, it kind of screws things up for us. Because remember, water is a byproduct, and so we don't want to have water added to this, otherwise it'll drive the reaction backwards. Okay, so fingers crossed. It's cool too, because we only have to wait an hour or so before we figure out if it worked. Teehee, welcome to chemistry. Okay, so I'm kind of getting annoyed by this water issue. So what I'm going to do is raise this up. And then I shall make sure it's good and dry. Okay. And then what I'm going to do after that is place kind of like an additional cover more or less like a seal. This is paraffin wax, and it's called parafilm, and you can kind of easily stretch this over a variety of things. So sometimes we'll use it in lab to cover up some stuff, just and if we don't have like a lid for a certain thing. And so let's go ahead and see if we can get this wrapped around here okay. It is a waxy, so it's going to obviously repel water, but it also is really kind of, it can get a little gooey. So we'll see how it is for now, but I kind of like the way that looks. I don't know about you, but I'm hoping that just kind of helps prevent water from getting in. Probably happen, but what you gonna do? What you gonna do with all that water? Let's see. Get this guy going. Make sure that stir is good. It is stirring. Our temperature is what is it? Okay, we went a little high. That's all right though. So I probably will still kind of tend to this occasionally. I'm just not going to spend the whole time in lab working on making sure that's okay. So I think that was a pretty good solution. We'll see how it goes. Here we go. You can see those bubbles is going all right. Let's see how this area is going. You can kind of see that the water, it might be tough for you, but for me, I can see it's doing its job, except for that guy. What is he doing? He's just, you can see it's beating up. Oh, you can see it's beating up and more or less just kind of sliding off eventually, but it's doing its job. We are about, sorry, let me see if I can get my watch. We are about 50 minutes in, so got some time left, so we can prep for the next step. Okay. All right, so there you are. It's been a hot minute. So I think I let it go maybe like 10 minutes extra. But because really the goal is to actually get everything to dissolve in there. But as you can see, let me kind of take this off. Hold on as I raise it. Raise that for you. You can kind of see that there's still white solid in there. So we'll see what happens in the end, but really what we need to do is let that cool, and then we're going to add it to a beaker, hit it with some water, basify it, and then to neutralize the acid that's present, and then we'll move forward hopefully with the precipitate that is our benzocaine product. We'll see. That water is messing us up. All right, so what do we have here? Got my reaction. Yes, I have a glass stirring rod. Okay. I also have a cute, adorable 10 milliliter beaker with 3 mils of deionized water in there already. And then I got the stirring rod that I'm going to use to kind of get all of that solid in a suspension. Okay, and then what I'm going to do is quickly pour that into here. Okay. All right, so you might be thinking like, whoa, dude, didn't you just say like we're not supposed to do that? Whoa, dude, yeah, sometimes. So here's the thing about the reaction moving backwards. It it's going to happen at higher temperatures at a much faster rate. So as long as we have this water kind of chill or at lower temperatures, then we're doing okay. Okay. So now that I've done that, got it in here. Yeah. So now what I want to do is add about 1 ml of 10% sodium carbonate, so Na2CO3. And what is this? What does that do? What is sodium carbonate? Base. Okay, so what that's doing is that's hopefully going to neutralize, most definitely going to neutralize, I don't know why I said that word, the sulfuric acid that's present, right? So why are we doing this? Well, let's see what happens first, okay? First of all, we want to just kind of, this is part of the purification process, or what we might call working up a reaction in organic chemistry, okay? And so I'm going to do addition of sodium carbonate to the point where it's about an 8 on the pH scale, okay? But what I want you to see, hopefully, is, let's see if I add a bunch of this, what happens? Well, something happened. Oop, you can kind of see it there. Let's see. Oh yeah. Well, that's the spin vane in there, and you can see it kind of bubbling up, right? Remember, sodium carbonate in the presence of an acid will form carbon dioxide, right? So that's kind of like our body's natural buffer system. So we have CO2 with some acid, like water or acid, it forms carbonic acid. So CO2 with water makes carbonic acid, and that can break down into CO2 and water. It kind of goes back and forth, or carbonate or bicarbonate, right? So let's see, we got this stirring here, and what we have, I'm gonna go ahead and check the pH of this. So the bubbling is still there, so you kind of want to wait till that subsides, because obviously if it's bubbling, then the base is still reacting with acid, right? So but I'm impatient, so, and I really want to tell you how to do this. So oftentimes I see students dip this whole pH strip in the reaction. Don't do that, because that's a terrible idea. So it's not detrimental, but it's just not good practice. So what's on this strip? Lots of stuff, right? So there's chemicals on here. So why would you put chemicals into something that you're trying to purify? Just doesn't make sense, okay? So what you really want to do is get a little bit on here and just tap, tap, taparoo, or tap, tap, tap in. Okay, so that's red. What does red mean? If you don't know, what you can do is refer to this universal indicator chart, and red is a pH of 1 or maybe 2. Okay, depends on your shade of red. Either way, it's not basic, right? We want it to be around 8, which means it should be that gorgeous green color, huh? All right, so let's hit it up with some more. Let's see here. Boom. 3, 4, 5, 6. I'd just say like I had 6 drops of that. Give it a little stir, stir, stir. You can see the bubbles forming still. So that means it's not, it is not done reacting, and it's not neutralized. Okay, so I'm gonna let it hang out for a minute. I'm not sure if you guys want to keep seeing this, but I'll see you in a minute. Okay, So just to give you a kind of more of a lab technique, I wouldn't normally hold that up. I would probably, I'm just holding it up to like for the sake of the video. So I would actually just put it on a stir plate and then kind of add while it's stirring. Okay, so you kind of just do like that, right? So, and then once the bubbling stopped, you would kind of let it stir a little bit, maybe turn that up so we get that froth out of there. You also just want to make sure that it's not too crazy so that it kind of splashes or moves your beaker around. Anytime you have something unsecured on a stir plate, you never want to walk away. And you might not even want to you might just want to secure it if you aren't confident with your skills or anyone around you. Because accidents do happen in the lab for sure. All right, you should you see snow globing. What's up? Snow globing, y'all. So what I'm gonna do is kind of try and get the liquid on the bottom. Come over here to my pH paper and then give it a little dab. It looks green. Let's see if it matches the green we wanted. Looks pretty close, right? Does that look a little bit more yellow to you? So maybe chilling on the 7 side or like low-key kind of like exact. I don't know. It's up to you on this. You make the judgment call. You can add more or not. But I do see a precipitate in here, so I'm just gonna run with it. I'm gonna filter it on my gorgeous setup right here. I'm sorry, I'm like the worst cameraman ever. So here's my setup. I got remember what this one is called? It's called the Hirsch funnel, right? It's the Hirsch McGirsch. It's the cone-shaped one, but on the inside, we've got some holes, right? And so we can kind of put that filter paper in there. And then you want to make sure that, woohoo! Ooh, did you hear that? Hooty hoo! All right, so really what you want to do is make sure that you add water to this so that the filter paper is suctioned on there and you don't allow your solid material to kind of swoop in like around it and then end up inside of this filter flask. Okay, so another thing about this is that if you aren't super confident with your skills, it's always best just to make sure that this is clean, just in case you mess up somehow and you have to gather this material that came through, typically just called the mother liquor. So, all right, I'll see you in a second. All right, so I have this guy chilling. He's frosty. It's about 4 mils. So here's some DI water. Remember, spray a little on there so it suctions on there. Remember we have a stir bar in there. What I like to do sometimes, maybe it won't work, maybe it will, is use another stir bar to kind of hold that inside of this beaker as I pour. It's better with a bigger stir bar, but we don't have any bigger ones in here. So you pour that right down, and you can see that we've got quite a bit of solid left in there. So let's pour some of this. And again, we want cold washes, right? That's because we don't want the reaction to move backwards. And just so we're clear, that stir bar situation, that didn't work. Again, it's better when you have like a much larger stir bar or magnet even to kind of hold that in there. But you can use that trick later on in life when you're killing it in the lab somewhere. As long as you got a bigger magnet. Okay, so making sure I get all that stuff off the walls. Pour, 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 stir, 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 pour, 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 stir, stir, stir. I think you get the idea, right? So we're trying our best to make sure we get everything to maximize our yield. Okay, so you know why? Because science. All right. Woo. All right, one more time. about three washes, 1 ml portions should suffice. Just what's a sufficient amount to wash with, whatever the procedure says. But if you are kind of doing your own procedure for the first time ever, then it just really depends on the amount of material that you have, and it's all about trial and error. So we don't have a ton of material. We don't want to use a ton of water because that does decompose our product and force it to go in the backward direction. And so we've got some material there. Here, now I can probably use this guy to, got him coach, got him. All right, so we want to let that hang out on the vacuum for a little bit, just so we can get a crude mass of the material. And then what we want to do after that is recrystallize in 2 separate solvents. So this is like a good bad combination. We've already done recrystallization, and so you should be familiar with at least using 1 solvent, let's say water or ethanol. You dissolve the material in the minimum amount of hot solvent, right? So this one is a good bad combination, so you're going to dissolve it in the minimum amount of good solvent, and then you're going to add slowly bad solvent, meaning something it's not very soluble in. And once if you're adding slowly and it starts to precipitate out, that means you need to stop, and then you add more of the good solvent to get it to the point where it just barely dissolves with both of those solvents. So we're going to be using methanol and water. You'll see it when it happens. We don't have a ton of material, so we're going to use the Craig tube. Okay, so it's been about 10 minutes on the vacuum, so I'm going to go ahead and be done with that. I'll scoop it onto weigh paper, which I've already pre-weighed to determine the mass of this crude material, and then we'll go ahead and put it inside of a Craig tube. So the Craig tube looks like this. So we've got the glass portion, and then we've got a stopper typically. So this is what we're going to end up putting our solid material in. Okay, so you don't need to see me weigh it out or anything. I'll hit you with the numbers though. Okay, so we got 176 milligrams of our crude benzocaine. And if you're wondering if the water affects the reaction, well, let's see. We add a little bit of extra, right? We also had water issues on our condenser. If you're wondering if those were an issue, even before analyzing the material, I'm pretty confident that we formed some product of benzocaine. The reason being is that we actually, when we were adding the base, we actually got a precipitate. Okay, so under an acidic environment, it was not soluble. It was soluble, and then under a basic environment, it was not soluble. So why would that be? Let me set this down while I talk to you. It's probably going to blow away, so I'll be careful. But think about the structure of the molecule. We have a benzene ring. We got an amino group here, NH2, and we have an ester over here, right? So in an acidic environment, if we could protonate something on the molecule, what would we protonate? The most basic site, right? That nitrogen. So what happens when you protonate that nitrogen? It is NH3 plus, right? So it's a salt. Salts are soluble in water. But what about the neutral state of that molecule? The benzocaine product, essentially. Once you remove that proton, it's no longer an ion anymore, right? So it's just neutral, and it's very non-polar, so it's not going to be soluble in the water. Okay, and then it crashes out. Bada bing, bada boom. Okay, so hashtag science, right? Because so now what we want to do is place this solid material inside of our Craig tube. Okay, give me a second. All right, let me explain what I'm about to do. So again, solid is going to be in here. Got it right here. We're going to heat it after we've added some methanol, and it's going to be hot methanol. Remember, if we heat the solid material before we start adding the solvent, then it could potentially oil out, and that's going to ruin the recrystallization process. And we don't want to do that because I've been here forever, and I'm not trying to screw things up. So, but it happens, even if you're trying to be careful. So, let's just try harder. That way I can go get a Red Bull, huh? Somebody told me I should get that peach edition. So I got that in my fridge, ready to go. So what we want to do is put the solid material in here, add just a little bit of methanol, maybe it's going to be warm, right? So we can put it in there, and then we're going to stir it up with our spatula. We're going to go like this, boom, 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 like a little KitchenAid or something. Trying to make some benzocaine cookies, and then once we get that dissolved with some hot solvent in there, and it's maybe doing all right, we can actually put this inside of our aluminum block, and you'll see that once I start doing this process. But it's a little block, and you can set a variety of things in there. So I've got right now, I got my water heating up, and I got my methanol heating up in the hood, because remember, methanol make you go night-night for good if you consume too much or inhale too much, okay? It only takes like 15 mils, depending on the size of the person, right? So, got the hood on, and being very careful. So what we do is we add that methanol to this. We're gonna end up putting this on the hot plate. We're gonna keep stirring constantly, and then we're gonna drop, just a couple of drops at a time. Stir it, let it get time to like kind of heat up or get to temperature, and then once it's not dissolved, you can add some more. If it is dissolved in methanol, then you want to make sure you do not add any more, and then you start adding slowly water, drops of water, and then give it a little stir, right? Water until you see it precipitate. After that precipitate, if you know you added, like, let's say 2 drops of water and then it happened, maybe add 2 more drops of methanol. See if you can reverse that and get everything dissolved. But either way, add a little bit of methanol to the point where it gets dissolved barely. Like, even it took 1 drop and then boom. So it was like drop, solid, drop, solid, drop, solid, drop, solid. And then remember, drop it like it's hot too. So drop, solid, drop, and then all dissolved, okay? So once you do that, you take it off and you let it cool to room temperature, okay? So this is such a small amount that it's going to cool very fast. And for crystallization, the optimal method is to let it cool slowly to room temperature, and then once it's room temperature, you put it on an ice bath and let that cool down as well. So you could technically put this in water to let it cool to room, like warm water to let it cool to room temperature, because the water will cool much slower than the liquid in here. And so we're not going to do that, but I'm just letting you know that's a thing. Okay, so I'm just going to let it cool to room temperature. Maybe throw it in the freezer because I don't have access to ice right now, and then hopefully we'll get some solid material in there. And then once we do, we put this on here. Actually, I'm going to put that on there while it's cooling. And then we're going to make a little copper thingamajig that kind of sits there with a little hooky hook. And then the purpose of this is you're going to pull it really tight. Okay, this always freaks people out. Take a centrifuge tube, slide that over, and then make sure it's touching the top right here, and then you can flip this hook over right here to kind of hold it in. So now once you flip it over, the liquid in here will stop at where the stopper and the centrifuge tube meet, and then once you put it in the centrifuge, centripetal force will shove all the liquid down. It'll seep through the cracks, and the liquid will end up in the centrifuge tube, but the solid material will end up right here on this stopper. Okay, and then you can just kind of gently open it up, place it on a weigh paper, and then weigh it out and analyze it. Okay, but really what you want to do is just make sure that it's really held together tightly, and then this will allow you to raise it out without separating the two, okay? Because if you just go like this, if you go like that, you're like, oh, my solids everywhere, and I ruined my day and my life, and this is the worst thing. So, yeah, let's get it started. Let's get it to it. All right, so I'm not gonna talk much because it's inside the hood, and it's really loud and it's an awkward position. So, this one right here is my methanol, and this one right here is my water. So I want to add my methanol first, okay? So here we go. Didn't mean to add that much. Damn it. Yep, that was my bad idea. See how it all dissolved? Crap, that's too much. But put it on there. We'll see. Gotta boil that down, kind of. This is the aluminum block. See how it all sits there? Looks pretty scientific, eh? Just waiting for it to boil off. I'm gonna go for it. Kind of boiled it down quite a bit. We'll see. Once I give it a shake, it goes back in the solution. Really close though. It's so right. Silly methanol jumping out of there. Ah! I don't know how much I put in there, damn it. benzo. Oops, sorry. You want to put here. It's already happening. Oh, there it is. Just let it hang out in here for a bit while you clean up. Okay. I'll probably let it cool for like 2 more seconds before I put it in the freezer. All right, here's the moment of truth. All right, so we flip it over, put it on there, and then bada bing, bada boom, and then flip it. Oh, it's still there. It survived. Now let's go throw it in the centrifuge tube. Remember, we gotta balance that boy though. All right, so there we go. We've got it all balanced out, and now we just gotta turn it on. Probably do like 3 minutes or something. You don't need to hang out for that, but you'll see the aftermath. Okay, though. So now we grab this guy, and you can hopefully see some liquids on the bottom. Yeah. Tough to see in this opaque container, but you can see it on the bottom, right? And now we got our solid right there. So that was in there for 3 minutes or so, and so it should be sufficiently dry to analyze. So let's check it out. Okay, so let's see if you can see it right there. There's a little bit of solid right here on right here, and then we also have some up here. So what we want to do is just make sure when we open it up, we open it over some whey paper. And I've already tared this, so I know how much the paper weighs, and I can just immediately weigh the solid material to get our final yield. Okay. So got it on there. It's 102 milligrams. Okay. So one thing I want to make sure you know though, like when you're walking, seal that baby up. That way those mouth breathers don't get you. But it's 102 milligrams. Let's take a look at the product. I smashed it, but some of this material still kind of looks crystalline. You can see like those shiny specks in there. So I mean, overall it was all right, but I think in general the recrystallization occurred too quickly. So you saw as it cooled, it pretty much, when I took it out off the heat, it's almost immediately started to form that solid material. And so ideally it would be slower, but I told you what you can do. You can put it in warm water and then let that cool down to room temperature, and then throw it in the freezer or ice bath or something. And so we're aware of the situation. Overall, the material should be pretty clean anyway, because what we did was we put it in, or we precipitated it out initially, right? And so a lot of that material was soluble, and then it wasn't, right? So think about the starting material, para-aminobenzoic acid. Imagine that. So it's got polar functionalities, right? That can hydrogen bond, and so maybe it's soluble in water already. But when we basify that, for sure soluble in water, right? So because when we add base to a carboxylic acid, we make a carboxylate, which is negatively charged, super soluble in water, and so there you go, para-aminobenzoic acid. And so that wouldn't be part of the material, maybe if we didn't sufficiently wash it during the filtration, some could have gotten stuck in there. But again, we recrystallized in methanol and water, and so it's gone. This is really clean. I'm going to go ahead and go out on a limb here and say it's pretty clean. Let's trick out the melting point. Actually, you guys have seen me do it like 42 times already, right? So you don't really need to see it anymore. I'll run it. I'll get you the data. I'm also going to do an NMR for you, and I'm going to get you some. I'm going to do an IR for you, and I'm also going to get you some NMR data as well for you to analyze. Okay. Hey, you can't see it, but it's sweating, and it started around 63. Okay. What's that mean? You got liquids in the air. Okay. Oh. Can you see it? I don't know how to do this. Anyway, yeah, you can. You can see that light through there, right? Yeah, so this is a good one. We'll see how it looks. All right, so that was kind of a minute. Lab takes longer when you're filming it, huh? So, just to recap, we did a Fischer esterification with para-amino benzoic acid to make benzocaine. And so we did do some new techniques, right? We did the Craig tube crystallization, but on top of that, we also did the good and the bad solvent. The good solvent being the methanol, the bad being the water. And then we got 102 milligrams of the final product. And then we also, I was just kidding too. I don't make mistakes like that. Not anymore. But for real, like, cover your product when you're walking in a lab, because you could bump into somebody, or somebody just walking quickly can cause like a gust of wind and blow your product off. And if you for real have been there for like 3 or 4 hours, pissed. You're not gonna be happy. And then that 102 degrees, that 102 milligrams of product. Again, you got to think about like the loss of that material. So there was some left in the Craig tube. It looked like a lot of material, so I wasn't about to try and scrounge up every last bit of it. And so it's all good. When I did the melting point, it did start to sweat around whatever I told you, and then it melted. It was a short range, but it was pretty low. You should analyze, or you should look up the literature value for benzocaine, and then compare to our range, which was 80 to 83, and then think about why that might be lower than it should be. And then on top of that, we did get a good IR, so that I'll throw on Canvas for you. And then I'll also throw an NMR of the material for you as well. Ours was acting up, so I gotta find one for you, but I still want you to get that experience because it's really good experience, and then it'll help you in the long run. So I believe that is it. Hopefully you had fun. I'm not gonna lie, I'm tired and I'm hungry and all that good stuff, but I had fun. So hopefully you did too.